Hey everybody. I am not positive about this, but I think the number of the day today might be 31. And if it's not, we can figure things out later on, but I'm going to go with 31 and we'll see what happens. But a quick couple of facts about 31. This is a puzzle. It's called the Tower of Hanoi. And how it works is you take one of these discs. We've got a side view of these circular discs, and you take one of them at a time. So I could take this top one off of here and move it here or here, doesn't matter which one, but I can only move one at a time. Also, if you take a disk and put it somewhere, you cannot put it onto a different one that is smaller than it. So if this one goes here, the next one would have to go over here. And then the next one wouldn't be able to go in either of those two spots. So the little one would have to move over onto the third one. And what this has to do with 31 is that if you have a 5-disk tower, it requires 31 moves to solve. And then if I have a circle with points on it and I connect those points with segments and figure out how many regions are made. So 1, 2, 3, 4, 5, 6, 7, 8. I'm just counting up all the, well, I guess the pieces of pizza, you might think of it. And if I look at the number of points connected to the number of regions, with 2 points, of course, I divide this up. I'm only going to be able to make it into 2 regions. If I have 4 points, once I get done dividing this up, we'll count up the regions. I've got 1, 2, 3, 4, 5, 6, 7, 8. And if I put that all on a table, it looks like this. And so it looks like if I have 6 points, we would have 32 regions. But it turns out if you do this with 6 points, you end up with only 31, which is a little surprising because the pattern, it goes 2 and then 4 and then 6, sorry, 2 and 4 and 8 and 16. But what follows doesn't stick with that same pattern. The pattern turns out to actually be this. When it looks like it's just 2 to the n power, it turns out to be this 1 and then 2 and then 4 and then 8 and then 16. And then things change after that. And it goes with this formula instead for reasons that we probably don't want to go into right now. All right, well, thanks to those of you who gave me some feedback. I've got a few problems for us to take a look at. The first one, this is from the 11.10 section, the last section. Specifically, I was asked if I could take a look at one of the other integral problems. I did go through one of the integral problems. I believe this was on the night when I recorded the notes, and there were some technological problems, and I ended up just posting the notes, and the video didn't end up transferring very well. But hopefully we can make it through this one. To avoid the problem that I was having that night, I've just written everything out, and then I'll just talk you through it on this slide. The question we're taking a look at is number 49, and asks for the integral of cosine of x minus 1 over x dx. We are not going to be able to just look at this and find an antiderivative. I don't know how to do this. It feels like it might be some kind of an integration by parts. There are no substitutions. Basically, I don't know how to do this integral by any means other than what we are going to do. And this is really honestly the usefulness of a power series, to say if I can represent this as a polynomial, well, we can always anti-differentiate polynomials. So that's the idea. For this one specifically, the manipulation that I'm going to use, I know what cosine of x looks like. I hope that most of you know what it looks like. I know that you'll all know by Friday what it looks like, but cosine of x is equal to, here it is, the first term is 1 because cosine of 0 needs to be 1. Alternating between positive and negative terms, cosine's an even function, so we're just looking at even powers divided by even factorials. So if this is what cosine is, then cosine of x minus 1, I'm just losing that first term. And then cosine minus 1 divided by x, well, since every term has at least 2 x's in it, we'll just get rid of one of the x's. We're dividing each term, lowering the power of each of the x's by exactly 1. And so this is the expression that we're going to be anti-differentiating. The integral of cosine of x minus 1 over x is the antiderivative of this. Now, one little detail, I don't think it's usually going to be a big deal, and how you deal with, well, you can do it in different ways. Basically, the antiderivative of this, when I do the integral, it's the antiderivative of this term plus the antiderivative of that term, et cetera, et cetera, et cetera. And then at the tail end of it, plus c. Problem with that, there is no tail end of this. And so I just put my c at the beginning. I said my constant of integration is at the beginning, c, and then the rest of the antiderivatives. Antiderivative of this, I'm raising the power of x, dividing by 2, raising the power of x like we do for all regular antiderivatives. And as I was working through this problem, the first one I got, I just called 2 times 2, 4. But then I noticed that the rest of them, the other antiderivatives that I've got written out here, I've got 4, excuse me, from the antiderivative of x cubed, but then I also have 4 factorial. And for the next term, it was 6 times 6 factorial. And so to come up with the general term at the very end of it, I thought it might be useful. Instead of calling this 4, I switched to calling it 2 times 2 factorial to fit with the rest of the pattern. This little step in here, this was just me trying to figure out what the value of this constant of integration was. And you can do this by just figuring out what is the value of this function, the function that we're trying to find the antiderivative of. What will it be at 0? And so I just plugged in the limit as x goes to 0 of this expression. I did a little bit of L'Hopital on this one to find that the limit of this one is equal to 0, which basically means my constant of integration is nothing to worry about. And so I've got the first few terms listed out. I decided to put it into sigma notation so I could represent it without the ellipses on the end. And it wasn't too bad. I've got the alternating behavior, -1. I wasn't sure if it was going to be n or n minus 1 or n plus 1. But then I noticed that in the first term, the power was 2, the factorial was 2, the extra coefficient was 2, 2, 4, 6, 8. And so it made sense for me to go with 2n for those even powers. And if I start with 2n, that means that first term needs to be at n equals 1, which means my power on the -1 was n, to make sure that I started with a negative before alternating between positive and negative. And so there we go. That was question number 49. I also looked at question number 68. I believe that's the last question that was assigned in that section, that was saying find the value of this. It doesn't even look like the same type of a problem. And so I thought I'd talk through my strategy on this one. When I looked at this, I noticed that I've got something and then something and then something squared over 2 factorial and something cubed over 3 factorial. And as soon as I saw that, I thought of e to the x, because I know what e to the x looks like. Again, maybe you're not quite there yet, but you need to know this one. Really know that e to the x is 1 plus x squared over 2 factorial plus x to the third over 3 factorial. And so as I'm looking at how similar this is to that one, well, it looks like I'm just substituting natural log of 2 in place of x, but also we're switching between negative and positive, which means if I plug in positive square root of 2, this one would be positive. I need that to be negative. So let's make that negative natural log of 2. Negative natural log of 2 squared would be positive, so that's okay. Negative natural log of 2 to the third power would be negative, and that's giving us our positive and negative. So since e to the x looks like this, I'm just replacing my x's with negative natural logs of x. I suppose technically this would be the answer, but I wanted to simplify this and see what it looked like. And so I applied properties of exponents and logs to say that e to the negative natural log of 2, that would just be the reciprocal of e to the natural log of 2, applying a power property that you guys learned back in probably algebra 2 for the first time. Something raised to a power, which is then raised to the power, you're multiplying these two powers together. So I can split them up the same way. E to the natural log of 2, by the definition of what exponentials and natural logs do, they undo each other. And so e to the natural log of 2 is just 2, 2 to the -1, 1/2. And then I honestly was a little bit skeptical, worried that I maybe goofed up somewhere, because that's a really clean answer. And so I started plugging some of these terms into my calculator, and sure enough, by the time we got to this fourth term, I forget, well, it must have been like a 0.49 something, or something pretty close to 1/2. So that one feels pretty good. And then I was also asked if we could go back and take a look at some questions, or at least a refresher on section 11.8. And so I looked at a few different problems there. Again, I've done some of those problems in previous videos, but I thought it would be useful to look at interval of conversion, radius of conversion, that kind of stuff. And so I chose number 13. There wasn't anything particularly special about this one, but I did want to do one where it wasn't just a negative one-to-one scenario. And so this is what I came up with to find my interval of conversion. I sent it through the ratio test, which is usually what you're going to do. I sent it through the ratio test. Here's the n plus first term, multiplying by the reciprocal of the nth term. I grouped these things together. I'm not too worried about -1 over -1 because of the absolute value. I've got 4 on the bottom. I've got one more 4 on the bottom than on the top, so that leaves me with 4. I've got one more x on the top than I do on the bottom, so that leaves me with an x. And then I've got a natural log of n over the natural log of n plus 1, which as n goes to infinity, that limit does go to 1. So we just have absolute value of x over 4, which means my interval of convergence is somewhere between -4 and 4. And if you want to lose points on a question, you should stop at that time, because we also need to take a look at those endpoints. Does this converge at x equals -4? Does it converge at x equals +4? And fortunately, the way we figure that out is just simply by plugging them in. Plug in your endpoints and see what happens. And usually it's going to clean up pretty quickly. On this one, when I plugged in -4, I've got -1 to the n, -4 to the n, and 4 to the n. So this is really just a great big 1. -1 times -4 is 4. 4 divided by 4 is 1. And so this is just 1. And so I've got the series that is just 1 over the natural log of n. And I know that that one diverges because I know how natural logs behave. 1 over n is the harmonic series, which definitely diverges. And natural log of n is going to be less than n, specifically when as n is large values. So once we get to 3, 4, 5, 6, the natural log of n is a smaller value than n, which means this fraction has a larger value, and something bigger than something that diverges must also diverge. And then I plugged in +4, same idea, except now negative times positive is negative. And so I've got -1 to the n times 1 over the natural log of n. And so now this is going to 0. This is alternating, and so this one actually converges because it is an alternating series. So it looks like my answer is that at -4, it diverges. So -4 is less than x, not including -4, but less than or equal to +4 because it does converge at x equals +4. Okay, I'm going to stop this video at this point, but I'm also going to do a couple free response questions. I didn't get any input about which of those free response questions to do, so I'm going to do 2011 just because it just happens to be on top of the pile that's sitting in front of me right now. And then I'm not sure what the other one's going to be, but it'll be one of the other questions that I got posted, one of the other questions I posted earlier. All right, there we go.